This morning's topic is what is the least bad way to cool the planet? And our speaker is Dr. David Keith. He is kindly permitting us to record today's discourse, so each of you will see an on-screen request to add your own consent. If you haven't done so already, please press got it to continue in our service. Dr. David Keith is a professor of applied physics at Harvard School of Engineering and Applied Sciences, and he also teaches public policy in the Harvard Kennedy School. He's worked near the interface between climate science, energy technology, and public policy for 25 years. He has won many prizes for his work and been recognized as one of Time magazine's heroes of the environment. And so he's my hero too. Best known for work on solar geoengineering, Keith's analytical work has ranged from the climatic impacts of large-scale wind power to an early critique of the prospects for hydrogen fuel. Professor Keith has built a high-accuracy infrared spectrometer for NASA's ER2 and developed new methods for reservoir engineering to increase the safety of stored CO2. I'm not sure I understand all of that or so many of the other things that he has accomplished, but he spends about a third of his time in Calgary, where he helps lead Carbon Engineering, a company developing technology to capture CO2 from ambient air. He shared with me that he is Canadian as well as American, and so we share our ancestry, and he and his family have attended Unitarian services and enjoyed them. So I want to welcome Professor David Keith. Professor Keith, I'm turning it over to you.
Thanks very much. Happy to be here. I'm going to start with some really general things about climate. And some of you will have heard this before and others not. Hopefully some of the perspective is new, because I think talking about this strange topics I work on, solar geoengineering and other things, only makes sense in the context of some picture about the climate problem. So let me start with the positives. I've been working on climate basically my entire career for 30 years or even slightly more, depending on how I count the start. So really my whole professional life. And there's no question that the level of attention to this topic is higher in the last couple of years than it ever has been. There really is a sense of political momentum, a way in which it is near the top of the political agenda in, well, it's the developed world, obviously a lot less right now with the war, but it's real. I recently talked to a colleague who told me that he'd been, a colleague who's in the US government, who told me that he'd been in meetings with quite a lot of US cabinet members, spending half an hour talking about solar, restarting the build of solar PV technology in the US, and who knows what will happen. But having those conversations at that level was just not happening years ago. So I think there really is something exciting. And I actually think that the kind of youth movement, the people like Greta and many others around the world helped to drive this. Lots of different factors did it. But it's clear that after years where there was professional talk about climate, and that we had the Framework Convention on Climate back in '92, and so it's not like it hasn't been there. It really is closer to the top of the political agenda. So that's fantastic. And I guess the other really positive thing has been a kind of dramatic decline in the costs of some of the important low carbon technologies, most importantly solar power, I think, that really was sort of unexpected and stunning, and I think makes it fundamentally easier to decarbonize our economies. So that's super positive. I think there's no question that it's possible to decarbonize our economies. What that means is basically shifting the kind of industrial basis of our societies, the industrial infrastructure that drives civilization, from fossil fuels to something else, to I think really large scale solar or nuclear power. And but I think that doing it fast is hard, and there are real trade-offs. No simple answers to what's the right way to do it. But I think it's important to say it's not just a matter of kind of easy consumer choice or getting electric vehicles. If you want to really get all emissions, you have to do a bunch of the big hard sources like supplies of cement or steel or other industrial products or the hard parts of transportation infrastructure. So I think there are genuine uncertainties about what the trade-offs are about how quickly we do that. I guess the single most important kind of physical science fact to know about climate is that the amount of warming and other climate changes this century are pretty much proportional to cumulative emissions of carbon dioxide. That sounds like just a not very interesting statement, but it's actually quite a profound statement. So one thing that means is if we stopped emitting, so if we get to the point where maybe we'll have some global celebrations, I would guess we will, where we have actually eliminated emissions. Maybe that's in 2050 or 2060 or whatever. That doesn't make the problem go away. It just stops the problem getting worse, which is a huge, huge achievement, but it doesn't make it get better. And in that sense, climate is very different from some other environmental problems we're familiar with. So another important way to think about climate is to think how big a problem it is or isn't compared to other environmental and social problems. And there's no simple answers to that. I think climate is the worst kind of globally coupled environmental problem over the century. But however bad it is, that actually is important to say that it's not, in terms of impact on humans today, it's much smaller impact than air pollution. So air pollution kills, there's a wide variety of estimates, but let's say 5 million people a year around the world. The number might be up towards 10. It's sort of epidemiological estimates of how many people die or have their lives shortened from air pollution, but it's a big number and it dwarfs the impacts from climate change or the impacts from water, for example. But a huge difference is air pollutants last in the atmosphere for about a week. So once we reduce the sources of air pollution, the atmosphere cleans up in about a week. And that sense is sort of completely different from climate. And we have made huge progress in air pollution, not just in the rich world like Europe or here, but China has dramatically reduced air pollution in the last few years. So it's clearly possible. I think we sometimes undersell the power of collective public action to make people's lives better through pollution control. The US Clean Air Act has added about 1.5 years to the life of an average American. It's really stunning. So that gives you some sort of sense of what we've done in the past. So there's no question that we can and must decarbonize, but decarbonization is only one of, I think, 4 fundamental things we can do to manage physical things. I mean, there's obviously different political things that interact, but there are 4 physical kinds of things we can do about climate. So one is to decarbonize our economies, to stop putting the CO2 in the air. And I think that's one where you have to say we have to do it. There's the only argument is about how quickly it's going to happen. But if you literally, if humans want a stable climate, you must eventually bring emissions to zero. The second one is to take carbon back out of the atmosphere. There are a whole bunch of ways to do this. They have a bunch of environmental risks and social consequences. It's often sort of thought in a kind of fuzzy way that doing this through planting more trees or other biological methods are somehow low impact, but that's not necessarily true. More carbon is not necessarily more natural. We are actually protecting a lot of forest in the western part of the US to have much more carbon than it naturally does, because we've done fire suppression, not necessarily a good thing from nature's point of view. So there are complicated trade-offs there, but there's no question humans can pull carbon back out of the atmosphere, and that's a way to reduce the kind of carbon bomb that we built for ourselves with industrial civilization. Then there's this thing that I mostly work on nowadays called solar geoengineering, basically the idea that humans might deliberately intervene in the Earth system and the Earth's radiative balance and the balance between incoming sunlight and outgoing heat to reduce some of the risks of climate change, but with a whole bunch of new risks and political threats. And I'll come back to that, because that's the main thing happy to answer questions about and talk about. And then the fourth thing is local measures that in some way break the link between climate change and human or ecological impacts. So that's everything from kind of high-tech things like more drought-resistant crops or seawalls to prevent flooding, but it's also a lot of social and behavior things. So collective action to get to old people who live on the upper floors of buildings in heat waves actually plays a really dramatic role in preventing people from dying in heat waves. So there's a big mixture of these things. So to recant, there's 4 basic things that humans can do: stop emitting, pull carbon back out of the air, do this solar geoengineering thing, or do adaptation. And I guess my view is we should seriously consider all of them, and that that a sensible strategy doesn't likely rely on one. So I'll say a little bit more, well, maybe say some of the sort of scary stuff about geosharing right off. So the kinds of technologies people are talking about are like deliberately introducing sulfuric acid into the stratosphere, which seems crazy, introducing a pollutant. And there are deep questions about it. I think there are a whole set of technical risks, but I think the central concern about talking about it, and there's been a kind of taboo, which I've been one of the people who's helped to break, or breaking, there's been a taboo against even doing research on this. And I think the reason has been that people justifiably fear it will divert attention away from cutting emissions, that it will be sold as a kind of technical fix, that kind of get out of jail free card that means we can just keep the fossil fuel party running. That, to be clear, is not what I think. It's not what really anybody researching this thinks, but it is, I think, a legitimate fear. Maybe put more bluntly politically, I think the fear is that interests which will be harmed by the transition to carbon-free fuels, so fossil fuel companies or fossil-rich nations, will claim that solar geoengineering is a get-out-of-jail-free card, will kind of use it as a political excuse to avoid emissions cuts. And so people, especially people on the kind of political progressive left, often have opposed research because they feel that it's sort of inherently bad for that reason. I don't think that's I think it's a real fear. I was one of the first persons to articulate the fear, but I don't think that fear is a basis for not understanding these technologies better. And let me say a bit why. So it's just a fact that for all sorts of hard social problems, we have more than one solution. Hard, complicated, real-world problems are rarely solved by some kind of magic bullet. And there are always trade-offs between the solutions. So there were people who argued that airbags in cars should not be allowed, serious people, in the 70s because it would encourage people to drive more dangerously. There are these things are called risk compensation. There are commonly arguments like this. In climate, Al Gore famously argued quite strongly, and he was not the only one, but he was obviously a leader in thinking about climate change, that we should not do any research or talk about adaptation measures because these local adaptation measures would take away from the focus on emissions cuts. I think in hindsight, Gore was wrong both empirically and ethically. And in fairness, he's changed his position. But I think he was wrong empirically because, in fact, what's happened since he was making those claims 15 years ago or so is that we have much more attention on cutting emissions and much more attention on adaptive measures to reduce risks, showing you that it is possible to talk about two things at once. And I think it's also wrong ethically because it kind of separates the causes of the risk, which are mostly historical emissions of the richer countries, from those who will suffer most. And it's just not ethical to say that we're going to restrict the ability of some of the poorest people who suffer the most to protect themselves by taking these adaptive measures. Because however we got here, if you're a young person living in Bangladesh, where I was traveling, talking to climate refugees almost two years ago today, however we got here, you surely have a right to think about how to protect yourself and how to reduce your risk, and your society does. So I think there are real questions about how that fits together. So that's a little bit of the high politics. I think another common concern about solar geosharing, and a common thing that people will say who think that there shouldn't be research, is that it's a kind of colonialist project or a project to extend humans' control over nature. And I think that's a complicated issue because, of course, the goal is to reduce the human impact on nature, but to use some technology to do it. And I think there's no simple answer there. And there are lots of cases where we do use human ingenuity and technology to try and repair previous damage. So I come from a family of wildlife ecologists, and as a kid, I was involved, actually got to help build boxes to reintroduce peregrine falcons, a kind of raptor that was damaged or almost wiped out, and was wiped out in Eastern North America by DDT, to reintroduce them. And this was very much an artificial project, a kind of geoengineering project. The falcons were bred in a big facility in Wainwright, Alberta, shared between the US and Canada, and with kind of trick, you take their eggs and put them under a prairie falcon's eggs, and then they were, flown around the country and artificially put back in these boxes. And it worked. It helped the falcon populations to recover where they probably wouldn't have. But it wasn't a one size fit all. That was only possible because we'd also managed DDT. And so that's a case where we both had to solve the underlying problem, which was the DDT that was destroying the falcons, but also do the reintroduction, because without that, the population might not have recovered. So I think it's not uncommon in thinking about ecological management that we do need to both deal with the underlying problem and find ways to reduce the consequences. So that's my view of solar geoengineering. And so I'm kind of a leader in research on this topic. And my view is that I truly don't have an opinion about whether it is the right thing to do. And I reject views that it is necessarily should be used or should not be used. These are inherently human political choices with a huge range of different views. My view is that it makes political and ethical sense to have a serious research effort, to have an international effort to learn much more about these technologies. And my view is that the balance of evidence is that they really could reduce human suffering significantly. So climate change, is, I'm sure a lot of you are aware, hurts many of the poorest people. And the reason is that high temperatures, or an added little bit of temperature, is much worse in places that are already hot. So if you look at estimates of death from heat, or economic impacts from heat, or also impacts on people's learning from heat, it turns out that, not surprising in a way, but when you learn things in hot days, you learn less well. You can see this in test scores in New York City schools and lots of other places. So an added bit of heat to a hot place is much worse than an added bit of heat to a cool place. So when you look at the only things that have been published, looking at the impacts of doing a little bit of solar geoengineering added on top of emissions cuts, you find that according to the models, which may be wrong, but the models that have been published, the benefits are actually most pronounced in the poorest countries. It actually reduces global inequality for that reason. So to me, that's a kind of moral reason to take it seriously, but not necessarily to do it. But I think it is to sort of come back to the concern. The underlying concern is that this is will be used or as an excuse to avoid emissions cuts. And I think my view is ultimately that's a political choice. And I certainly believe we should drive emissions down very quickly. But there's no simple right answer about how to think about the trade-off between these various measures. So maybe to come back to the title of that of the talk, that was the title of an op-ed I wrote in the New York Times last year, which was the least bad way to cool the planet. There's a bit of trickery in there. Let me explain it. It is because of the thing that I said, which is a fundamental piece of climate knowledge, that the warming is proportional to cumulative emissions. It is true that cutting emissions won't cool the planet. Cutting emissions stops it getting warmer, which is a bit of a sort of tricky sense, because there's no question that we have to cut emissions. But whatever we do to cut emissions, if you actually want the future on a kind of human timescale of a couple hundred years to be cooler than the past, at any time, if you want it to get cooler, you have to do either carbon removal or solar geoengineering or some combination. Cutting emissions won't do it. Cutting emissions just stops adding to the problem. So my view is it is important to think seriously about how we do those things, and how we do those things in a way that is legitimate and just in some way. Yeah, that's most of what I want to say. I'm really happy to get questions and answers. I want maybe just say one or two more words about sort of where I think we are now. I do think the level of political attention is higher than it's been. It's fantastic. I think we're kind of at the end of what I used to call the phony war in climate, where politicians would make statements that were, grand statements at climate conferences about what was going to happen, but would really do nothing. At this point, real money is flowing. The world is spending about $300 billion a year on clean energy, which is probably about, in my view, 1/3 as much as it should be spending. It should be spending more like $1 trillion or more. But real money is being spent. There really is this build out of solar and wind and other clean technologies. Electric cars are really, I think, really are set to take over light duty vehicles. But I think if you look at the actual policies in many of the economies, they're not the kind of policies that you would need to really drive emissions down at the level of ambition that's talked about. So people talk about bringing emissions towards zero in 20 or 30 years. I think that's doable, but extraordinarily hard to do. It would require a kind of wartime level mobilization, which may well be the right thing to do, but I think we're not yet at the place where people are having a kind of a honest public conversation about the trade-offs of doing that. And yeah, that's why I'm happy to talk to folks like you today, because I think finding ways, this isn't something that's owned, just by experts like me who've worked on climate my whole career, but it's in the end owned by all citizens. Have to kind of have discussions about how to think about the trade-offs, because as much as climate is a huge problem, it's one of many problems, and we need to think about how to balance efforts on climate with efforts on social justice, efforts to reduce other environmental threats, efforts to reduce risks of war. So thanks very much. I'm really happy to take questions. Look forward to it.
Thank you, David. That was very, very interesting. And so now for questions, I invite the congregation to ask their questions with a request that comments and extended questions be reserved for the breakout room. So if you have a question, unmute yourself, or raise your hand and I'll call on you. And then please mute again after your question. Okay, Gloria, keep it short and please proceed.
Okay, the question I have is because my husband is an astronomer and he always brings up the energy trade-off of producing panels using fossil fuels such as coal in ovens, whatever, the big furnaces in China. And I was trying to find some articles. It looks like some progress is being made. Could you speak to that?
For solar panels, the energy cost of making them is tiny compared to the energy that they generate over their lifetime. So I'd say there are problems with toxic metals and with some of the production chains in China, but I don't think that there's really that much of a problem with energy use. And partly this is a sort of the energy used per panel has declined as panels have got much cheaper because the whole process has got so much more efficient. So I think that's an issue for some other things, but not really for solar panels.
Good. Okay. And I was glad to hear that the US is building back up toward solar panels. Other questions? Call out if you, Kelt.
Yes, another topic you didn't comment on, but is one that certainly has been a controversial one with the pros and cons for years, is can you say anything about the status of nuclear energy contributing in this world?
Yeah, I'm happy to try. So if you ask people, I'm not going to try it as a poll, but I've done it in my class. You ask people what are the bad things about nuclear energy. I think there's sort of four big ones: cost, waste, risk of reactors and risk of proliferation, risk of the weapons being used. And what is interesting is that people order those very differently. So when I asked my class of Harvard students that question before having the nuclear lecture recently, many of them put waste at the top and proliferation at the bottom. I would put the order exactly opposite. My understanding is that the risks of waste are really very small. They've been exaggerated by people in the environmental community who wanted to use that as a tool to block nuclear power that they felt should be blocked for other legitimate reasons. But the waste risks are compared to other risks of energy systems pretty small. But I think the proliferation risk is real. And I think that if we did have a world that embraced nuclear power as a way to reduce carbon emissions, we inevitably make it easier for people to get access to materials to make weapons. I think the fundamental good thing about nuclear power is that it is physically compact. When we think about decarbonizing our energy system, we have to think about solving the carbon problem, but not creating too big other environmental problems. And some methods that we would use to generate the kind of energy that humanity needs will themselves have other big environmental impacts. So hydropower, for example, biofuels, and it's more complicated, but in some ways wind power, if done at the scale of modern human civilization, will have pretty large environmental footprints and impacts. So the reason I sort of cryptically at the beginning said solar and nuclear is I believe that only solar and nuclear could be scaled to produce enough energy for all of modern industrial civilization with a pretty small footprint. And so in that sense, I take nuclear pretty seriously. But the fact is the nuclear industry is just failing, and it's some complicated failure of loss of public trust, of rising reactor prices, of industries that have just not operated well. And it's really hard to understand how you would rebuild the public trust and build a nuclear industry that could make sense. But I guess I say I'm in favor of doing it broadly, but I don't quite know how to do it. And I feel like I can argue either side of the pro or anti-nuclear world. I guess I'll say one thing on, it's easy to be over worried about risks. So at Fukushima, the two people who were most exposed, or three, I think, who were workers who were in the plant who walked into high radiation areas, they got doses of about half a sievert, which will probably mean nothing to any of you, but that turns out to increase your cancer risk over 30 years, about the same as a diet change. And those were the two most exposed individuals. The risks outside the plant were essentially zero. There were big risks because they did an evacuation, which upsets people, and then there's knock-on social effects. But the damage was the evacuation, not the radiation. And that's pretty objectively, I mean, unlike some other things, it's easy to measure radiation, and we know the risks pretty well. It's actually easier to buy a radiation measurement than an air pollution measurement. So you don't have to trust the government. This is pretty basic stuff. And even at Chernobyl, you know, the number of people killed directly was sort of 60. The number of people killed indirectly is, you know, 1,000-ish or thousands. But to put that in perspective, at that time, the fleet of coal-fired power plants in Europe was killing 100,000 people a year from air pollution. So I think it's important to think of these risks in perspective.
Interesting. Very interesting. All right. More questions? Joanne, you have to help me on this because I can't scan. Joanne, all right, Joanne, you're
Kirsten had one and Bill had one. Kirsten.
Okay. It seemed that recently there's been a downturn in interest in wind. And was it in the Netherlands there were protests against it, and it's not catching on very well, it seems like a really natural thing to me, a natural wind. Do you have a comment on that?
Global wind power capacity is growing very fast. So while there are certainly local protests, the wind power, there's more wind power generated than solar globally, and it's growing very quickly. So in terms of low carbon energy production. It's the fastest growing source. As was mentioned briefly in introduction, I was one of the first people to do estimates of the wind power itself has climate and environmental impacts, and I worked on that. I don't think that means we should have no wind power, but I think it means we should be concerned about very large amounts of wind power. And overall, to me, it means we should think a little more about solar and a little less about wind.
Okay.
I mean, to put this in simple terms, if you wanted to run all of North America on wind power as a sole energy source, you basically have to cover North America with wind turbines.
Okay.
That's a bit of an exaggeration, but not a huge exaggeration. Whereas if you want to run all of North America on solar power, you have to, cover some portions of Arizona with solar panels. It's really a difference in scale that matters.
Oh. Good. Bill?
Yes, I'm wondering how we can depoliticize this whole issue. In spite of the Greta effect, especially on younger people, she was excoriated by then President Trump and other people. Obviously, there are big corporations that stand to lose, coal and fossil fuel producers. But can you think of some ways we can depoliticize this issue?
No, maybe you can help. I mean, I'm being a little glib, but I actually do think that there's interesting ways in which faith-based organizations or other organizations that kind of cut across American society in other ways may have an important role. Some of you probably aware of Catherine Hayhoe, who's been very visible as somebody who's a climate scientist and a evangelical. She's also Canadian. I've talked with her a couple of times. She's pretty terrific in trying to reach across some of those divides. I don't know. I'd say that I almost think climate's the least of it. I am deeply concerned about the level of political division in the US. It really does seem, every generation thinks things are terrible. And I'm guessing you're a few years older than me. I don't know if it's really worse, but my sense is when I ask people who are a lot older than me, people in their 80s or 90s, they do think that polarization has got worse. It really seems just disturbing. And I think the pandemic, in some ways, polarization, it both showed and reinforced polarizations in a way that is just truly disturbing. So I almost feel like climate is not even at the top of my list of concerns for the US, but I guess I'm just rambling. I don't know. I think the answer is, if we can't find a way to reach across the divides, we can't solve the problem. There is a positive sense that there is much more agreement that climate is a problem by polling than there was 10, 15 years ago. And certainly there are a substantial body of moderate Republicans who agree that doing something about climate needs to be part of the game. But both sides need to compromise. I think the Biden administration has made mistakes in overemphasizing some of the climate justice agenda, which I think is not the most effective way to make progress and secure the bipartisan middle. But I'm not really a political strategist. I'm just giving you my 2 bits. But I guess bottom line is I do think both ends have to compromise a little bit.
So I have a question, and that is, can you give us a bit more understanding on the geoengineering
Sure.
things that can be done?
Yeah, I didn't say much about it. So the method that's best understood is putting aerosols in the stratosphere. So let me just define terms. So aerosols are just little particles of solid or liquid that are just so small they take a long time to fall down. So little tiny dust particles, or we talk about COVID aerosols. So in the stratosphere is about, in the tropics, it's about 15 or 20 kilometers over our heads. In the mid latitudes, it's less. So in the tropics, it's almost twice as high as a regular aircraft flies. In the stratosphere, air moves very slowly. It takes 2 years or something for air to move through the stratosphere. And so aerosols in the stratosphere can last for years, and they get distributed pretty evenly around the stratosphere. Whereas in the troposphere, the lower atmosphere, tropos is turning sphere, and I should know if it's Latin or Greek, I don't even remember. But the whole lower atmosphere turns over kind of roughly once a week. And so there's this very sharp distinction between stratosphere and troposphere. So putting aerosols in the stratosphere can produce this kind of even mixture. And for solar geoengineering, the idea is that you would deliberately put sulfur or other aerosols into the tropical stratosphere, where they would then come over the whole planet in a pretty even way. And that what does appear to be clear is that doing that is ridiculously cheap, and that you could do it in a way where the amount was in some sense small compared to natural effects we've seen. So big volcanoes put sulfur in the stratosphere, some of them. So after the Pinatubo eruption, the last really big stratospheric aerosol eruption in '92, the whole world did cool about 1 degree. And that Pinatubo eruption put 8 million tons of sulfur in the stratosphere in 1 year. So what people like me are proposing for solar geoengineering would be to put about 1 million tons each year, but continuously. But the fact that Pinatubo did 8 million in 1 year, I think gives you some, it doesn't prove that it's safe, because it's not safe, there's going to be risks, but it gives you some sense that we know something about the unknown unknowns, because nature has done something like that. There are a bunch of other ideas of putting other kinds of particles in the stratosphere. There are ideas about altering some high cirrus clouds with a kind of cloud seeding. There are ideas about making some lower level clouds whiter. So all of these are broadly part of solar geoengineering. And as I said, the topic has kind of been a taboo, but that's changing. And there's now, 1,000 papers published, but still a pretty small number of researchers really actively working on it, and really strong disagreements about whether it should be researched.
Very interesting.
That,
Other questions? Okay, so
Kirsten had her hand up.
Am I allowed to have another one?
yeah, sure.
Okay, so solar is the one of the better ways. Is there, and this has to come to after our experience with recycling, does individual homes and so forth having solar panels, is that likely to have an impact of any sort on the whole world's problem?
I mean, every little piece matters, for sure. But my view is that solar panels on individual residences don't make a lot of sense. I mean, people should be free to do them, but I don't think it's a cost-effective way to spend public money. And the reason is our electrical grids are very efficient. So our electrical grids, the whole US electrical grid is about 94 or 95% efficient. So only 5% of electricity is lost in transmission.
Wow.
And it's much cheaper to put solar panels in big arrays on the ground. Cheaper to maintain them, cheaper to install them, and they actually produce much more energy per solar panel because they're oriented correctly and they are clean. And so my view is, if we're going to spend public money, what ultimately is public money, on cutting emissions, it makes in general more sense to do solar panels in big arrays on the ground and not on individual homes. Because on individual homes, the maintenance costs are very high. They're often not pointing in the right direction. It's different. I think there's intermediate where you get big warehouses. I think that can, with flat roof warehouses, can be very efficient places for solar. But I think solar on homes has been I think it's useful, but it's not the be all and end all.
Thank you.
What about requiring everybody to paint their roofs white?
I think it's worth moving in that direction in cities that get very hot. I think a hard requirement probably isn't the right answer, but some kinds of incentives in urban areas are a good idea, because it can reduce what's called the urban heat island effect, where urban areas get relatively hot. I do think so. I think, yes. But it's complicated. Yeah.
Okay, all right. Well, that's my idea of how we can replace the snow cover that we're losing so rapidly.
Yeah.
Anybody else?
I think total building size is so small, you're not gonna, I think that's where, if you want to stop the snow melting, that's where you should consider solar geoengineering, which does it evenly. But I think for reducing urban heat island, because high temperatures really do harm people, and it also drives up air conditioning energy loads, I think there is a real argument for roof whitening, yes.
Gloria?
Here. Hi, my husband walks to work and we have one car. We live in town. You know, you're talking about all kinds of technological things while people still string out, you know. What about infill?
For sure. I mean, part of this is about changing patterns of lifestyle. I think it's important to say that cars are, maybe it would surprise you how little they are of US emissions. So you know, of order, I should get my numbers probably uncalibrated, but about 15%, maybe a little bit less actually of US CO2, about 15. So cars are important, but they're not as much a be all and end all as you might think. I do think dispersion and kind of urban sprawl matters. Air travel matters a lot. But ultimately, I think if we're really going to cut emissions in a kind of, you know, 30-year-ish time scale, make deep emissions cuts, I think we're not going to fundamentally change the kind of distribution of where Americans live. We have to do it by decarbonizing the energy system and by reducing some excessive consumption, especially too much long distance travel, which I'm guilty of.
And what other ideas are you working on or others working on for the geoengineering pieces?
So for the solar geoengineering, I'd say there's a sort of going from the top to the bottom. There are ideas that I think are kind of science fiction about building a shield in between the Earth and the sun. I think in the next 20, 30, 40 years, that's just really is science fiction, but it's a 150-year problem and access to space has got cheaper. And so there's actually some real interest in this idea. I think it's not utterly crazy. And it is interestingly different politically from these other ideas. Then there's this stratospheric aerosols, which is the most thing that gets the most research, where there's a big range of research, understanding the aircraft, understanding the chemical impacts, understanding what kind of aerosols you distribute, a whole range of research. Then there's these ideas of moving down. Cirrus clouds, high clouds tend to warm the planet and low clouds tend to cool the planet. So if you could reduce these high clouds, that could have an effect. There's a very interesting connection there to aircraft contrails. So aircraft warm the planet both from their CO2 emissions, but also for making contrails. And there's ideas for reducing those. Then these low white clouds in some kinds of marine areas, there's an idea of spraying sea salt aerosol into those clouds that could make them whiter. And then finally, there's ideas about making the land surface whiter by changing crops or, well, what you said about surfaces of buildings, but there's really too little building area to make a climatic difference. So that's the kind of range of things for solar geoengineering. Then there's carbon removal, which you can also talk about as geoengineering, but I think carbon removal is a better word, but nobody owns the words. And for that, there's a big range of ideas from manipulating ecosystems to, you know, low-till agriculture, some things that are just small changes to what we already do that make sense, to direct removal of CO2 from the atmosphere. And here I'm conflicted. I do have it's not in Calgary anymore and I'm not very active, but I did found a company kind of by accident. I don't really think of myself as a business person, but that company is actually doing very well now that's trying to develop technologies to capture CO2 from the atmosphere. So there's a big range of different ideas there.
Mm-hmm. Mm-hmm. Gloria, you had another question?
Just the final one. I was looking at this, putting the, it's not the sulfur dioxide into the atmosphere, but that's what causes acid rain. So,
Yep.
You know, is that not a good, is that a non-starter because of that?
No, I don't think it's a non-starter, but that's a good question. I think the total numbers matter. So I can circulate, actually, I didn't show slides, but I've got a public talk where I go through a bunch of this, including that in detail, a long talk. I can circulate the pointer to it. But humans now put 50 million tons a year of sulfur in the lower atmosphere from fossil fuel combustion. So 50 million tons a year, which has this big air pollution consequence and acid rain. And the acid rain really comes from concentration, where there's a lot of emissions in one place. For solar geoengineering, we're talking about 1 or maybe 2 million tons a year in the stratosphere, where it would come down over the whole world. And acid rain really is about local concentration. So I think actually that's one thing we can really say for confidently. There isn't an acid rain concern. It's just not enough to acidify in an interesting way.